Welcome to skill number 62. I can extend area, perimeter, and circumference formulas to circles and regular polygons. This is an extension of skill 61, so we will rely on a lot of the formulas we learned for skill 61. So the formulas that we learned in skill 61 are listed here. If we wanted to add perimeter in there, we could say the perimeter of a square is 4 times the side. We could also, like a rectangle, refer to the perimeter as 2 times base plus height. The parallelogram uses the same perimeter formula, 2 times base plus height. A triangle has a perimeter of side 1 plus side 2 plus side 3. And then the rhombus and trapezoid both have a perimeter of side 1 plus side 2 plus side 3 plus side 4. Finally, the only difference for us is the perimeter of a circle we actually call circumference, and the circumference is calculated 2 pi r. And we'll see this equation on the first page of our notes for this lesson. We'll begin our notes for skill number 62 on page 62A. And we first start by defining that the perimeter of a polygon is the sum of the lengths of the sides. We saw that on the last page. And then also the perimeter of a circle we call the circumference, and it can be found with the formula circumference equals 2 pi radius, 2 pi r. Our first example asks us to find the the perimeter of the figure. And in this figure what we have is a rectangle with a semicircle on the end of it. So to find the perimeter of that area, what we have is 3 sides of the rectangle and the semicircle. So let's first figure out the perimeter of the left side of the figure, which is going to be 10 inches plus 6 inches plus 10 inches, or a total of 26 inches. And then the circumference of the semicircle. So what we want is half of a full circle, so half of the circumference will be half of 2 pi r. The 2's cancel and you get a value of 3 pi. 3 pi is approximately 9.42 inches. So our total distance around is going to be 10 plus 6 plus 10 plus 9.42, which is 35.42 inches. On page 62b, we start to discuss how to find the area of a regular polygon. But in order to do that, we first need to know what an apothem is. So the apothem of a regular polygon is the distance from the center of the polygon to the midpoint of one side. And once we know that, we can calculate the area of a regular polygon by saying area is 1/2 times the apothem times the perimeter. I won't show how this is derived too specifically, but if you want to explore it yourself, the basic idea is you have several triangles that are being added up to get the area. So example 2 walks us through this. Find the area of a hexagon with side lengths of 10 inches. I'm just going to pull this up and zoom in. Alright, so what we have here is a hexagon. It's got 6 sides, and each side is 10 inches. So we know that the perimeter is 10 times 6, or 60 inches, but we don't know the length of the apothem. And oftentimes that's the hardest thing to find in this sort of problem. So what I've done is I've pulled aside just a triangle with the apothem over here. And we know that the base of the triangle is 5 inches because that's half of the total length of 10. And we're trying to figure out the apothem length, which we can do if we know the angle. And in order to find the angle, we actually have to remember that the sum of the interior angles is n-2 times 180, which means the sum of these 6 interior angles is 720 degrees. So each angle itself is 120 degrees. Now we have a right triangle that bisects that 120 degrees, so we know it's 60 degrees. From there, we can use right angle trigonometry to figure out the length of the apothem. Tangent of 60 is opposite over adjacent, or apothem over 5, and we find that the apothem is approximately 8.66 inches in length. Therefore, the perimeter is 1/2 times the apothem, which is 8.66, times the perimeter, which is 60. And we work that out to be 259.8 square inches. This is by far the most difficult area calculation that we have of simple geometric figures, because it relies on us remembering how to find the measure of the total interior angles, how to find the measure of each individual angle, how to find perimeter, and how to do the right angle trigonometry. So this skill is several skills wrapped into one. On the skill test, I probably will phrase the question very similar to this. Find the area of a, maybe I'll say pentagon with side lengths of 5 inches, or a octagon with side lengths of 20 inches. All in all, the process will look very similar to this. The only difference is perhaps our angle winds up becoming different. Our side length will change. On the next page, I work through another example where we have to calculate the area of another shape. So let's take a look at that. Here you're asked to find the shaded area, and in this diagram the shaded area would be the area of a circle minus the area of a regular polygon. And I didn't draw it on here, but it's assumed that this polygon is regular. So we need to figure out first what is our circle area, and then find our pentagon area. And if we subtract those, we will get our shaded area. So in step 1, I found the pentagon area, or actually just the apothem, and I did that by first looking at a triangle, length of 10 inches on the hypotenuse. I calculated the angle. Notice 5 sides minus 2 times 180, and then we divide that full distance by 5. So each of these angles is 108 degrees. 108, which means half of that for the triangle is going to be 54 degrees. Using the sine trig function, we find out the length of our apothem to be approximately 8.0902. This is not enough because we need to also find the perimeter, and we don't know anything about the side length. So in step 2 we go about finding the side length. And I used the same triangle. I said cosine of 54 is x over 10. And that gave me a value of 5.8 for the x, which is half of the side length, which means the total side length would be double that. So approximately 10 point, what is that, roughly 10.74, I think. Ultimately, we double it and then multiply it by 5, and we get a full perimeter length of 58.778. Finally, we're able to do the full area calculation, which would be the circle minus the pentagon. So pi times 10 squared minus half times the apothem times the perimeter. And if we plug that into a calculator, it all works out to having an area of 76.4 square inches. Most likely on the skill test, this is how I'll phrase the question, because it has us do a area of a circle equation and an area of a regular polygon. Alright, for skill number 62, we extended the area addition postulate so that we could use regular polygons. So we found out how to calculate the area of a regular polygon, and in order to do that we need to know the length of the apothem, and the apothem is the distance from the center of the regular polygon to the midpoint of one of the sides, and it will always occur at a right angle. It's important that this formula only works if our polygon is regular. Finally, we did some perimeter calculations and some circumference calculations.